We're winding through the end of the day, standing between you and some drinks somewhere, I think. My name is Rick Moy. I'm with RiskSense. We're a proactive vulnerability threat management company, and I'm pleased here to introduce Juanita. I have trouble with her last name. Koilpillai? Koilpillai, all right. I'll just call her Juanita for now. She's had a long history, over 30 years, hard to believe, in security, very accomplished, and she's going to talk to you today about the software-defined perimeter. All right, so thank you.
How many of you are familiar with the software-defined perimeter concept?
Software-defined what?
Perimeter?
Network.
Hadn't heard of it, not network, software-defined perimeter. Okay, so the couple of people from a company called Bitter and Verizon and people within the Intel community and the DoD community actually came up with this concept. And it's a combination of multiple things. This is a very technical talk, so I'm hoping that's okay. I'm in the risk management track, so I'm not sure how many of you are risk officers. No? Most of you are in the CISO's office? Yes? IT? Good. Okay, so we can be a little bit technical. So I put in some slides to talk about the problem, which is addressing some of the risk managers' needs and primarily addressing the changing perimeter, right? Because of the prevalence of devices, your mobile devices, your Internet of Things, the perimeter is changing. The monitoring and logging problem that most CISO organizations need, they need to look at data, they need to verify, they need to show compliance. That problem is hard. And addressing mitigation and resilience, helping the organization understand how to mitigate the threat, which everybody knows about today. Can identify, can detect, can respond to very little, unfortunately. So the whole purpose of the software-defined perimeter is to solve these problems. In particular, I'm going to talk today about the open source software-defined perimeter project that's being funded by the Department of Homeland Security. We kicked it off a couple of months ago, and I'll have some links, and you can join and see the problems that we're trying to solve. As you can imagine, they're not easy problems to solve. There are commercial versions of the software-defined perimeter already in existence, being deployed in large companies like Coca-Cola. There's press releases about that. The goal for our project is to allow medium-sized organizations to withstand a terabit per second distributed denial of service attack. So the goal is pretty high. And to provide the metrics so we can measure the performance of how the software-defined perimeter is working, and also to share information through organizations like the Cloud Security Alliance, like the Department of Homeland Security, like organizations like you guys. So I'm out there, talking and educating more and more people about the whole concept. So what's the difference between what we're doing today and what the concept of the software-defined perimeter is? The primary goal is to provide a need-to-know access model, which the DoD has been using for many years and have been using it very well. There's the concept of device attestation before authentication, which is also a concept that has been used a lot in the intelligence community. And the protocol called the mutual TLS, mutual transport layer security, which has been around for many years, but hardly being used for some reason. They may use one side, the server-side certs, but not the client-side certs. They may not know that to use the latest version because it's built on SSL, and it's the later version of it. So the software-defined perimeter took these concepts, put it together, and came up with an architecture that could use these mechanisms. So there are a couple of protocols that the software-defined perimeter concept came out of. One was a single packet authorization. Has anybody used single packet authorization before?
Kind of like Fort Knoxville?
Kind of like Fort Knoxville, right? It's a very neat concept where you close your firewall, and the firewall you have deny all rule. It's possible, believe me. You don't need to have all the traffic coming through your firewall. Just deny all. You know, you say, that's easy. How do I let anybody come in? Well, they should knock, and they should validate themselves and verify themselves, and then they can come. Right? So this is not revolutionary, right? This is like common sense. So let's start common sense. Let's start saying, close your firewalls, close everything on your firewall. You drop all packets. You only allow packets that are legitimate, right? So that's what the single packet authorization capability is about. The benefit of this is that you can blacken your server. Nobody needs to see your servers or your services, whether they are on-premise or in the cloud. That's huge. They can't see you, they can't scan you, they can't find you, they can't attack you, right? It mitigates denial of service on TLS because you can't find you, right? You have very specific connections to users that are authenticated, devices that are authenticated, and authorized to get it. Because you're dropping all packets and you only have the single packet authorization, you can start collecting this data that's very specific to who's coming, right? And you can start gaining this knowledge about all the unwanted traffic, right? Now that's what you need to be analyzing. And your good traffic needs to come in. You don't need to analyze good traffic. Good traffic needs to be allowed to come in, right? So that's the whole concept of a software, a single packet authorization. The mutual transport layer, I'm sure most of you familiar with this. Do I need to go through this? No? You? All right. So this concept is to provide device authentication prior to enabling any kind of confidential communication. Yes.
So how's that different from like SSH server keys?
SSH
Server
is based on that concept, right?
So
Right. And the servers on the server, from server to server, both the servers are authenticating each other, right?
right before you even
talk.
authenticate, right? The server to server key.
That's correct. So this is from the client to the server as well, right? And with a lot of traffic communicating web-based and web connections, you want to have, that's what this protocol is designed.
You're talking about the client, the endpoint authentication, or the user authentication?
Both. You need to do both. You need to do user and endpoint.
So you've got two certificates on the one for the user and
One for the device. The devices, a lot of devices have codes on them already. You know, they have GMAC codes, HMAC codes, use those. And then you've got your user certs that you can establish, right?
Don't you, for device attestation, don't you really need to have like a TPM?
That-
Sort of a digitally signed.
Or digital,
Firmware.
yeah, hardware fingerprinting is preferable, right? If you have control for critical applications, if you want to, with that level of control, you know, like military communications apps, of course, you're going to put it in hardware, right? Hardware device fingerprint, right? For typical websites, you know, you should gauge what kind of application you have, you know, how far do you want, how much you want to take your keys.
My question was gonna be that, I mean, it seems like this is, it's a very special case application because, you know,
Is it?
well, I'm saying maybe like if you have like, maybe like in a certain business, if you're distributing the devices and you already have verified firmware on them, et cetera, I don't know. I mean, it seems like it would have to be pretty specialized.
Not necessarily.
But I don't know, maybe there's something else you're gonna show that would make it generalized.
There are some hard problems here to solve, right?
Yeah, no, it's all hard stuff.
Right. And you want to pin the user to the device somehow, so that all communications from the edge devices to the server can be monitored and managed somehow. Right? This is about securing your stuff. This is not about compliance,
But I don't think,
right?
would you agree that today, when you're not, like, if you have a TPM or however, you have a TPM, let's say, and you can use a digital certificate to sign the software, this is the firmware, then you can do device identification. But otherwise, you really will never know for sure unless you can actually verify that the firmware on that device has official firmware on it. I mean, there's always a way to, so I think it's still not, it seems like
It's not 100%
it's not
if
there.
it's not in hardware, right?
Yeah, exactly. It's not a
And but how much of that do you need for the general application? If you know, not knowing what the device is specifically, but if you know the user that's on the device, there's some level of trust you can
That's a different thing.
establish.
This question is right. I mean, if you can authenticate the user
Correct.
using mutual authentication,
Right.
but the device you still.
It's just a speed bump, it's just another in-depth.
That's correct.
It's not 100%.
Not 100%, but you've got the user and the device pin, right?
Yeah.
And then from then on, all communications are pinned to that user and device. That's the hard part. That you cannot do at the IT level. That's my point. That's what I'm trying to say here, right? You can't solve cybersecurity at the IT level. Everybody has agreed upon that and said that. But how do you do it? What do you do?
Well, I mean, I would say that for one thing, people do already use mutual authentication. Not everybody, but there are applications. Depends on how you put it together. But of course, in general, people using web browsers
Right.
generally are not. I mean, they're
Right. So why not? Why can't we ask those questions?
Oh, I agree.
Right?
I agree with
Right.
that.
Instead of saying, do you have these, 10 gazillion compliance things, why can't we ask a simpler question? Why not? Right? That's the whole point of this presentation. Simple questions you can ask and answer and make sure you're doing it in your organization. Let's not make this more complicated than it needs to be, right? This is why cybersecurity is where it is. Because we've tried to make it so complicated with 21 different control tools that we have to implement, and then make sure that all those tools somehow magically hang together to secure your enterprise. Well, is that going to happen? Seriously? It's not. So, if you look at today's environment, it is complicated. You've got edge devices, a ton of them fly around. You've got your gateways and your applications, right? And then you've got these enterprise computing, storage, and data analytics. Everyone wants to collect data, and everybody wants to, make sure your company is running efficiently, so your data has to work for you, right? So what the software-defined perimeter is saying is, when you have edge devices, you have to make sure that they deny everything, deny connections. Only do the connections that you need to have. You want to authenticate to your gateways using very well-known secure protocols, like the mutual TLS. Use the client-side certs. You want to mitigate the theft of keys, and if you want to do that, you use your hardware fingerprinting, that you can do. And you can, at the edge device, use authorization to elevate trust, right? And single factor authorization is one of those things.
I have a question. Your TLS authentication is step 2, or is it not necessarily the steps?
It's not a
It's just
flow, it's just the
bullets?
things, these are elements.
All right.
You want to see a workflow? I have a link that you can go to Prezi and look at the workflow, exact workflow. We can get geekier.
Right,
That's
so
because-
but the single packet authentication, just to make sure, it should happen before you start TLS, right?
Exactly.
So it's just, I'm not
That's
crazy,
right.
right?
No, you're not crazy.
Okay.
That is it, right? You want to onboard
Sure.
users and devices.
Right.
Then you start your communication.
Right.
Correct. And at the gateway, same thing. You can deny all connections. Only allow legitimate connections in. This is not a complicated concept. So when you go back to your organization, you can start this practice. You can say, hey, deny everything, only allow legitimate packets through, right? You should be able to do that today. Technology is here, guys. You should do it. And then you should be able to require authorization to make, before you start to initiate communication. Require people to get authorized first. And for specialized users like admins, right, you should allow them to come in through very specific IPs, maybe use multi-factor authentication. These are all technologies that are available today. So at the enterprise level, you can, enforce audit logging, application whitelisting, file integrity, monitor this stuff. right, at the enterprise level. Your users, your servers are working away, you know, but you can do this whitelisting and monitoring with technologies that are available today. So this is the basic underlying concept of the software-defined perimeter. It's not very complicated, it's actually a simple concept for today, but putting it all together and using it in a framework is important, right? It's not 1Z, 2Z technology, it's making it all hang together.
How would you do number 9 on the previous slide specifically?
Which one?
In communications to
Number 9. So, you want to, how do you pin communications?
yes.
So you have, once you authorize, you know, those keys are all separate, identity keys, authorization keys separate. You can have within your application, right, keys that you use for communication that are associated with the user and the device. Why not? This is not a hard concept. This is another key that you're using
Isn't it
for.
cumbersome to maintain?
No, because you're building your applications already today to do that. So why isn't it built in?
So you're saying like if the user was not on that device, you
Yeah.
wouldn't let him in?
No, you're not.
Right, and I agree with you, but
Right.
it's still a challenge because there's not a real good way to have an authentic certificate on any generalized device, unless somebody is using it.
And maintain it too.
Well, maintaining, you know, eventually, you know, there is like, you can in a way, I mean, you can, if you're using like secure boot, you know, like Microsoft has secure boot,
Mhm.
Intel
That's
ship.
right.
So if you have something like that,
Mhm.
you can absolutely guarantee that there's integrity from the very beginning of the firmware.
Mhm.
You would have the beginning of what could be an infrastructure that is completely secure. But if you don't have secure boot, or something
True.
like it, a UEFI, something like that,
True.
you actually.
But these are good conversations to have in your organization. These are really
Right,
valid
but they're
conversations
not-
to have in your
we don't
organization.
know
And these are
what-
not unsurmountable problems, right?
If
These
the infrastructure's not in
technologies
place,
are there.
The infrastructure is not, it's a good thing to do. It's absolutely
Correct.
correct. We have to go with cloud,
Yes.
Internet of Things and all of that.
That's correct.
But we're not.
No, you're
We're
not
not
there.
there.
No, but you're not there even with the current
We
tools
should be
today.
able to do it.
We should be able to
We
do
should
it.
be able to do it, but
Wouldn't
it's
you
not
rather
just-
have this conversation than, you know, how should we do incident response
Yeah,
and,
but let me
right?
ask you a question.
Okay.
You know, practically most people interact using a web browser. I mean, a lot of people use web
They do.
browsers. You know, devices they use apps.
They do.
So you're not going to go from, you know, quickly to mutual authentication unless you're using like a specialized client. If you're using a specialized client that already has built in mutual, you know, authentication on both ends, right? You can do it.
I think what we're
Yeah.
here. I think we're talking about here is different business cases, different business scenarios. What I'm thinking now, I mean, I understand what you're talking about, and I throw away all the e-commerce in this, you know, because obviously nobody cares about, you know, as long as you have a credit card, whether you connect securely or not, right? All the communications that are between non-trusted parties also out because you can't really, right? Establish a trust.
It's a specialized.
So what, right,
Yes.
so what we're talking about though is can you apply this model for the business that is distributed? And you have, I don't know, a local office in Hong Kong and here and, you know, in London, and all of that is basically big one perimeter, because essentially the keyword here is perimeter, right? So we want to bring all that into kind of a one hardened
Perimeter
and
that
that's
you can
what I
control.
think that- I think
So-
And that's
what-
the
what-
purpose for this.
That is the
No, I get you.
challenge that
What
you
is-
know
what-
they're trying to
So
solve.
this would be in contrast to like, you know, like why not use a VPN? Why not use a VPN?
Exactly.
Right.
Exactly. There are so many other solutions,
Yes.
but you know, why not to use this?
This
I mean,
is-
what-
it's a
let's hear
legitimate
it out.
concept.
I mean, let's think about, you know, what.
Well, and integrate the
what-
VPN with the users and the devices that they're using and the
My-
servers and all the communications that are riding on the VPN, right?
Okay, one big challenge I see right away is that, and it's a chicken and egg problem,
It is.
how you distribute this initial certificate, how you get the certificate
Well, you could use a
on that.
different element.
Because if I'm physically here, why do I need all this, right? If I'm not physically here, how do you get it, right?
Can I ask you, the risk of getting shut down, especially when it comes to booting, if you could distribute unique VMs to people, and each one of check sums different, but then you know is that VM, a little VM on a USB, boot off of that. You got your certs in it, you know.
There you go. So you've got different ways of implementing it. The architecture and the concept is viable, right? So
Each one's going to have
each
holes.
one's gonna
gonna have different problems, whether it's this problem or that problem, they're different trade-offs, but
the
What are
underlying
you trying to
thing,
solve?
what you're trying to solve is this perimeter that's growing. You have to solve it, right? You can't solve it at the IT level, right? You have to bring it up to the application and how it's behaving and how you're going to onboard the users and how you're going to onboard the devices, right? How you're going to share the keys. These are conversations that are security-related conversations that must be happening in your organizations, right? That's why I'm here, to force your companies to have these
I think
conversations.
that when you're looking at user, the thing that's going to happen, from a user point of view, you're going to use what's already available, it's easy to use. VPN is already readily available, whether it's a
True.
SSL-based, but I think
True.
what you're saying, and I think you're 100% correct, is that once you get to the Internet of Things and you have to authenticate devices, you need something
The scale,
more. You need
exactly.
something more.
Yes,
Yeah.
you need to be able to scale it.
You need to identify, attach a human being to a device.
Correct.
So that you can trust. it.
Right.
Yeah.
And you have to start having this conversation about trust,
Sure. Yeah, I agree.
right? Yes.
less confusion. In my mind, the biggest problem today is how do you know the endpoint is an element.
Right.
Right, that's
Yes.
even, like you could have two-factor, this and that, but the endpoint's home, and someone's, they're watching over your shoulder, you're dead. At least with a VM, you can check some, you could even validate the
Right.
VM just with that before you even go through.
Correct. And if you have, your
It would have weaknesses.
correct.
right?
And if you have specialized clients, you're going to check some of the clients too, because the minute you put a client out there, it's
Right.
going to be reverse engineered in seconds, right?
Right.
And so, how do you know it's your client, and how they're doing it really?
Yeah.
These are the problems I feel like organizations need to be spending time on. I think we need to. It's time to start having these conversations. Yes.
I mean, in the defense of SDP, this is the architecture that's been used by Coca-Cola,
Yes.
Verizon,
Correct. Yes.
Staples.
That's right.
And now the CIA for interagency communication.
That's correct.
So it's been well tested. It's actually very simple. It's just the icon on your smartphone or your device. You click on it, it opens up a window that just prompts you for a password. But in that 1 second it takes to open it, it's checked the register, it's checked the private key, it's checked it's checked to make sure your device hasn't been compromised, it's checked the geolocation, it's checked the time of day. So it's not a granular thing about access or no access. It's not a binary thing, it's much more granular. So there's levels of trust, and that trust will determine which assets you're able to access. So if you're in your office, you probably have a higher level of trust. You can access more assets. If you're traveling, you can have a lower level, and not all the assets may be available.
That's
Are those
correct.
organizations doing security? Are they doing like a boot there for the firmware, or do they?
Well, Coca-Cola's
Because if they
machines
don't,
probably
you
do.
really can't. You theoretically, I mean.
They ship those machines. They own those machines, right? The Coke machines they own.
Yeah, they're also looking at secure browsing.
So, and then you can have plugins to do secure browsers, right? So
It's the right
I'm
direction.
arguing
I
it is.
totally
I'm
agree with you. It's the
arguing
right
that this
direction.
is the direction
It's
to
right,
go.
but it's still, the thing is, I mean, there are definitely challenges in this space.
Sure. Right? And which challenges are you going to fight? Are you going to fight the challenges that the traditional cybersecurity vendors are, telling you about, or are you going to really start solving this problem?
Yeah, right. I completely agree with you, but the reality of it is that people don't move to technologies until they're manageable. And if you can't,
I'd like to see the rest of the slides.
So for those who don't know what software-defined perimeter is, the basic workflow is take a web service or web services out there, your client, right, whether it's on a workstation or a server or a phone, or can request an API service, right? So you've got a bunch of APIs to do the request. You've got a controller which allows you to access your servers that are hiding behind what we call a gateway. The gateway is actually a perimeter around your protected assets, right? Your clients cannot access those assets without the controller and the gateway working in conjunction to have some level of control check before you have the access. So your control plane goes through the controller, and then once you've done that check and all the parameters that check out, you establish this mutual TLS directly with the server, right? And that's where the data is flowing. So this allows you to really make sure that on your firewalls, you have a deny all rule, and this will make sure that your mutual TLS can be completely secure. All right. There are versions of the software-defined perimeter with the controller and the gateway out there where the mutual TLS tunnel is not, fully secured communication-wise, but it's a start, right? You can put a controller up, you can put a gateway up, and get going before you finish the whole loop, before that whole mutual tunnel is all the way, right? Today, it'll probably stop at the gateway. And then your protected service can then say, okay, these are my APIs, and then I get redirected to the protected service. So there's an out-of-band kind of communication that happens before the actual communication takes place between your client and your service. So what he was saying before, you can integrate the controller with the PKI server if you've got that level of trust that you need for some users. You can, fingerprint have fingerprinting services that you can fingerprint your devices. You can make sure the users are onboarded properly. You can have software attestation, so you can attest the clients that are connecting to your server. You can have location services, so you can see where your users and the devices are located, right? So you can, and then you can also integrate if you've already got an identity provider, or an Active Directory kind of thing. You can have your controller interface with the Active Directory. And analytics is like a backbone. Every single piece of this data you're collecting so that you can monitor and make sure your perimeter is established and set and working right, all the way from the client to the server. Not just the network layer, right? Not just layer 2, layer 3, layer 4, all the way. The full stack. Versions of this that have been implemented. We've been doing tests now for the last 2 years with the software-defined perimeter and the Cloud Security Alliance. More than 100 million types of attacks. People have tried many ways to get in. Can't get through the very first SPA authorization layer. Because everything is dropped. Even we've given out the IP of the server, we've given out the credentials, but you can't get in because you have to be attested to a specific device before you can log in. You can't log in from anywhere. You have to be the user that's authenticated on a device to get in. Yeah.
But if you snippet packets, you would see the one that got in. The only way around that is if you were using like the equivalent of one-time passwords, but using
That's
that
right.
for the token.
Correct.
Then,
so there's a layer
then
you can use.
repeat it.
You can repeat it.
Right.
So you use like a very simple, that single packet authorization needs to be very simple, right? From tests that have been done before, they've used a special agent ID with a one-time password and a HMAC or GMAC key, right? And anything else is like too complicated. So we're looking at, with the open source version, different ways of encrypting that packet. What's the header? What's the payload? So you get all that data once we start doing, the research on how quickly we can do this. How quickly can you drop packets? So, because you need to be able to drop packets like crazy, especially for distributed denial of service attacks, before you allow that one legitimate, traffic piece to come in.
By the
And
way, none of your sites indicate anything about a device, though. They seem to be like a user oriented.
right, because I'm talking about the open source software-defined perimeter, so we're not focused as much on the device per se, but focused on dropping packets for distributed denial of service attacks.
Because the device part is the part I was looking at. That part is hard.
It is
It's a lot
hard.
harder. It's not.
It is hard. But some of the chip vendors, like the Intel chip, they've got these things called
Sure.
GMAC keys in there that you could use. They're really powerful, TPM kind of capabilities in these chips already. And we should be leveraging that. Right?
Yeah, absolutely.
Yeah. That's where I want us to spend our time, leveraging these really cool, neat capabilities to solve this problem. I have a link that I'll leave behind that walks through different workflows. If you send me an email, all of these slides should be up on your websites wherever you can access it from. I'm not sure, we should ask the conference guys. Send me an email. We can include you on the open source software working group. And all of the stuff we're talking about, discussing, about implementing, how do we implement this, what are the problems we're encountering, is all there. I would encourage you to join, and learn. And as we're, doing our tests and our research, we'll put the data out there so you can use it within your organizations. Changing the conversation around is not easy within your organizations, but you have to start somewhere.
Is there a commercial version?
There are commercial versions of it. Vito is selling the capability with the gateway and the controller for applications, so you can onboard applications. But there's mostly proprietary implementations of this because the technologies are out there to implement this at the application layer. It's a matter of education and encouraging the development people to use it, the business owners to understand that this is a way to secure your applications, right? One of the ideas that we had with the distributed denial of service project was for U.S. websites, U.S. government websites. U.S. citizens have access to it, right? Why should anyone else have access to it but U.S. citizens? Well, all U.S. citizens have phone numbers, so why can't we pin phone numbers to users and then allow all communications from that phone to be verified, and then type in a code or something like that on your website to get access to U.S. government websites, right? Simple techniques, technologies like that. We have this concept of connect.gov anyway today. So extend that all the way down to the web server itself. So this is a different way of thinking about risk management, right? It's not what they call systemic risk. It's looking at all the threats out there. Is it happening out there, right? And how do we protect it? Well, start systematically mitigating your risk one step at a time. The number of risks that you can, and type of cyber attacks you can mitigate right off the bat is huge. It's a huge list. If you authorize only the connections you want into your organization, then you don't have to worry about it. Questions? Yeah.
If I Google OpenSDP,
Yeah.
like,
You'll see the working group. You go in there and you request to be on the working group.
so all the
So-
info is just Google OpenSDP.
That's correct. It's a very interesting concept,
And you said if we email you, that's for that way?
No, I'll put you on the working group, and it's we've got a project in Basecamp that you can have access to information that we put out there. Yeah,
You put that up there.
that's correct. We'll put all of this.
Your
This link
email.
is up there.
Put your email.
That's right.
So just to make sure, is it still the open source part of it? Is it still in the concept, or is it the software implemented?
So the open source project right now has the port knocker, and we're updating the port knocker project to add SPA packets, so that for very specific use cases like system admin, you can use that, right? You can use it today.
Right.
The next step is to work on a trusted browser, like a plugin to like a browser, so that you can have the client send the SPA packet as opposed to you manually doing it, so that you can start creating a perimeter right away with browsers. So that's the next step. And then we're going to have to start testing for distributed denial of service. So that's the next step, because that's the project we're working on right now for the open source. But anybody can start joining in and start working on an open source version of the things that you're worried about, right?
Are there any big corporate enterprises involved in the project?
I'm not sure if I'm allowed to say yet, but for the testing part, because you can imagine we have to start generating terabit per second distributed denial of service attacks. Yes.
But they're like IBM, or no one's involved with writing the software?
No.
Okay.
Why would they?
A lot of companies.
They should have done it and put it out right now, right,
No, I
for
mean, a
people
lot
to
of
use.
companies like OpenStack for virtualization, there was like a big support from enterprises, even
Correct.
though they don't own it, they just contribute to it. I didn't know if there was some
Yeah.
feedback.
So no, financially not yet, but through the Cloud Security Alliance, we're starting to get the word out. It's a huge community that's involved in that organization. So we'll see, little by little, people will start jumping on the bandwagon, right? Yeah,
No, it's great.
it's different.
Is it,
What?
is it mostly Linux? A lot of the different components, or?
The different components are C-based and Java-based, so it shouldn't be restricted to
Java-based
and
or-
C-based.
Oh, C.
Yeah, so
Did you
it
compile
shouldn't.
it?
You should be able to compile on Linux. You should be able to compile on Windows, right?
It's just me, I mean.
It's a software. It's a
just
software-defined
mutual
perimeter.
authentication,
It's
right?
yeah,
It's
and a
mutual
combination of it.
authentication. I don't-
Correct.
I
With
don't-
port knocking.
In comparison to VPN, if you're like looking to connect to two organizations and be on the same network, I don't see the advantage. I don't see any big advantage at all. But I do, unless you're implying that like the cloud or cloud.
Yeah, you're not going to be able to set up
You want
VPNs.
to get to device identity.
You do
So
need to
maybe
get it.
That's the idea. But I don't see like if I asked you what would be the advantage over using something that's readily available today as a VPN. What
It
would-
is. I mean, it is. If you just look at the controller and the gateway,
Like you
you
said.
can look at it's like this giant, VPN, high-speed distributed VPN,
You're just using.
right? It's the same kind of concept, but it's more than that, right? Because you're having the trust levels and elevating trust levels.
No, explain that part. How is it? Is it better? You're saying it's doing more. I mean, compare it to IPsec.
IPsec is
what are
at,
the advantages over IPsec?
well, because you're doing this at the application layer. That's the difference.
You could do, you can have a VPN at TLS
This-
level. You go to TLS based.
You could have a TLS based, yes.
I think the difference is that the VPN is all or nothing. So once you connect it, that's it. Yeah.
But you can put any traffic you want.
Right, but what they're talking about is that you're limiting basically, you would whether you connect or not to begin with, but once you connect it, it's also not all or nothing. Right? So you leverage the application level security because it's on that level on the other players. Sorry.
So what this is doing is allowing legitimate traffic over your VPN. Right. Not just anybody can connect through the VPN.
I think it's, we all need to get to the point where you can identify the device and the person, put them together. I think that's really
I would like to,
that's
for all of us to be working on that challenge, more than any other challenge.
But I don't know that you, I don't think that this is.
Yeah, this is an
might be a
architecture,
part of
right?
it.
It's an architecture. It's an architecture.
Yes, exactly.
Right.
It's
How you
architecture.
implement it is depending on your
Yeah, that I agree
organization,
with.
your industry, your devices,
So if you wanna
your
leverage it,
software,
if
right?
you want to leverage it, make something of it, but you have to build infrastructure around it. So if you needed this today, you would probably just go get a VPN. You would, but if you want to invest and build around it, yeah, it's another architecture that you can leverage. I agree.
Right? Gotta start somewhere. So, yeah, sure, start a VPN in the cloud. Right? Any other questions?
Juanita, thank you very much. Thank you.
You're welcome.
Get everything turned off there so